Hello out there to you. In this video, we're going to think about a problem from the UK. How do we know that? Well, we're in British pounds here, and we're maximizing with an S. So everything is cooler in another country. Here we go. A profit maximizing monopoly has a cost function of this. The variables we're using here are a little different than what we have in the US. So this is cost of y. So we're saying that the y units is what we would see usually as quantity. So this is the cost of however much quantity you want to produce. So we're using y for quantity. F is going to be the fixed cost. So this is 10 million pounds, and you're just going to plug that into there. Okay, and it faces an inverse market demand curve of what is the price for how many units? It's 12,000 pounds minus 2y, which is really like 2q. If it charges the same price on the all units, what quantity does it sell and at what price? And then there's a second question about the government making a price ceiling that doesn't exceed marginal cost. So we're gonna we'll put that over here. Whoops, that right there. I don't know why the government would do such a thing, but perhaps it's a important product or something like that. So to solve this, we need to figure out marginal cost equals marginal revenue. And to get our marginal cost, I'm going to write this a little bit more US centric, I guess. So this is like saying the total cost. It's like the total cost function you might run into in a lot of classes. Oops. And may need more room here. Okay, so it's 10 million. I'm just going to put 10 million pounds like that. Well, no, I'm not. Put out all the zeros. So there's 10 million pounds plus, instead of using y, I'm going to use q now. I'll show you why in a second. And then the marginal cost is just the partial derivative with respect to q of this. So this is a constant. And then we're just going to take that partial derivative of that. So it'd be like 2q. Now, the way this is worded, if you needed to, you could say that that's like saying 2y. You could say those are equivalent because we're using y as a quantity variable in this problem. That's fine. Okay, then we want marginal revenue. So we've got this. We need a marginal revenue. So we need to get the total revenue and take the partial derivative of that. Let's try to do that as fast as possible. So we've got, so I write this as total revenue. So I'm going to multiply through, because that's an inverse demand function, I'm going to multiply through quantity, because total revenue, let me back up a second, total revenue is price times quantity. So in this case, this is the price. So I'm just going to multiply a q through there. So it'd be 12,000 q, or if you'd rather, you can use y, 2, and then q squared. Suppose I use the lowercase q over there, so I'm going to use the lowercase q over here. Okay. Then our marginal revenue is partial derivative of that. So we're going to kind of ignore that. It's just this. So it'll be 12,000 minus 4q. Okay. Set both of these guys equal to each other. And then we're going to solve, and we should get whatever that profit maximizing quantity is. Now, to skip a little bit ahead here, I think it only does do it once. Yeah. I'm going to show you. I just went ahead and graphed everything. Now I graphed it in graphing calculator. You have to substitute anywhere you have a p. It's going to be price, but we're going to use y because in economics that's the y-axis. Okay. So that's very confusing the way this problem is written. Well, we're going to use x because that's the quantity variable, and that's what we want on our x-axis. So then we get a real traditional looking monopoly here. And then we just find marginal cost equals marginal revenue, and that happens at 2,000. So what quantity does it sell? We now know that because we just looked on the graph there. So 2,000. And then we've got here, what is the price? So we find the price. You got a couple options. What you could do is you could fill in that quantity into this inverse demand function. So if you put in 2,000 right here and solved for P, you would get this answer. We're just going to follow this all the way where it hits the demand curve. So it hits the demand curve at 8,000. Okay, so 8,000 is the price. So this would be the quantity, or the Y value according to this problem, and then the price would be 8,000. And that's the answer. Okay, now the government wants to set, now it's a monopoly price. You can see it on our graph. You can see that that price is above average total cost, and there's a markup above there's a markup above marginal cost. So the government wants to set, what are we saying? So that the price does not exceed marginal cost. So we're going to say price equals marginal cost. You could do this algebraically. You just set this equal to the marginal cost, and then you would get the quantity, which is 3,000. And then the price has to be 6,000. So if they set the price at 6,000. Now the problem is the firm here, are they still willing to operate? So we're going to say price 6,000. That would really be like the price ceiling. And then the number of units would be, let's go back and find out. The units would be 3,000. So we're going to produce 3,000 units. And we're going to be suffering a loss as the firm. And let's see, as long as that loss is less than £500,000 pounds, we will produce it. So the way to figure that out, I'll just do that without looking at my graph, is I want to know what's the average total cost of producing 3,000 units. And I'm going to then see, no, actually, I don't even need to do that. I can do it like this. I can say, what's the total revenue of producing 3,000 units? And so that would be price times quantity. So it'd be 18,000 pounds. Okay, that's our total revenue. Got that from price times quantity. And then what's our total cost? It looks like no way. 10 million. Oh, the number of zeros is wrong here. Yeah, that's not the right total revenue here. So let's get that correct. Let's go 6,000. I didn't do enough zeros. 6,000 times 3,000. It's 18. Yeah, that's better. So 18 million. Okay. What's our total cost? Our total cost, we're just going to use this cost function here. 10 million pounds plus y squared. So y in this case is the quantity, so it'd be 3,000 squared, which should be something like 9. I think it's like 9 million. So 3,000 times 3,000. Yeah, 9 million. So that would be 19 million pounds. And so the explanation here is that no, the firm would actually not operate. They would exit this market under this condition because the government's only giving them 500,000 pounds and their loss is going to be 1 million pounds. So not a good policy if you want to keep this business in business. So price ceilings typically don't give us good results, but in this case we can actually see the answer there.